Hi, I'm Fraser Lewis. I'm from the Faulkes Telescope Project in Cardiff in South Wales, and also from the National Schools Observatory in Liverpool. I'll be talking to you today about how to use real data to teach astronomy and how that works well and the things we need to watch out for. So I'm very lucky. I work for two separate projects that have time on 2-meter telescopes that in fact all three telescopes have time allocated to educational resources. So in this diagram, you'll see the yellow dot represents the Liverpool telescope on La Palma in the Canary Islands, and the two red dots are the Faulkes telescopes, Faulkes Telescope North in Hawaii, Faulkes Telescope South in Australia, and they are part of the larger Las Cumbres Observatory network of robotic telescopes. So these telescopes allow me access to the night sky in both hemispheres and allow me to collect data for both research and for educational projects. As a result of this, I've worked with the National Schools Observatory for several years, creating resources of the inquiry-based science education type, so IBSE type, sometimes known as IBL, inquiry-based learning. And these are kind of project-led resources. So these are not resources where you go step 1, step 2, step 3. These are much more open-ended, much more of a research type project, and not the types of projects we expect students to work through in, let's say, 30 minutes or an hour. They're designed to be teacher-free, so we hope that we've put enough material in there for the students to find their own way through. This is the first one I did. This is about open clusters, the Hertzsprung-Russell diagram, life cycle of stars, and it's introducing students to photometry as well, using screencasts and screenshots. In this instance, it's behind a password. So you'll see the web link at the bottom of the page. We've put some of these resources behind a password so we can kind of track progress. We're interested to see how long students stay on each page to get a feel for what interests them and what routes they take through the material. It's very easy to register. I'll explain a little bit more about that later on. In this instance, we provide a sample data set of an open cluster. The students perform photometry. They do that using a free package called Macali, which is designed by the Japanese. And from that, then we provide extra data sets they can use to take their own, to take additional measurements and then do a compare and contrast of different open clusters. The final step in that, what we hope in a sense, is that the students then take ownership of the project and go off and find data, collect data on their own open clusters. They can do this using the Faulkes telescopes through LCO or through the Liverpool telescope, collect their own data. That gives them ownership and a different sort of level of pride and ownership with the data they've collected themselves. The second project that I created is on exoplanets. It's using the exoplanet.eu website, and it's taking the data from that website to do population samples. So looking at population studies of the various properties that exoplanets have, such as planetary mass, such as orbital period, radius, and so on. It encourages the students to plot one thing against another thing, very much as astronomers do, and to try and look for things such as, groupings, clumpings of data, or trend lines, proportionalities, and so on. Again, web link is at the bottom of the page if you're interested in that one. And finally, in terms of produced finished resources, this was one we worked on last year with support from the UKRI, the UK Research Institute, and they allowed us to work on what was in a sense a citizen science hybrid with an IBSE type project. So looking at how far we can take citizens in terms of knowledge and in terms of education before we start to lose them because we're bombarding them with information. So in this instance, we're looking at data sets of type 1a supernovae. We're providing the background material on what supernovae are, specifically what type 1a supernovae are. We provide instructions on how to do the photometry, this time using JS9, which is an online photometry tool, and mirrored in a sense on the DS9 FITS viewer. Again, we provide screencasts. We provide Excel sheets as templates for the students to put their data into. This allows them to calculate the peak brightness of supernovae and then to calculate the distance to the host galaxy. This feeds into the work that was done several years ago, and in fact, initially by Hubble in the 1920s, to create the Hubble Plot, measuring the expansion and age of the universe. So quite a cool project to go from supernovae and life cycle of stars right up to the broadest and biggest questions in cosmology. In this instance, we are working with the Gaia alert stream. So Gaia, the European Space Agency mission, provides a series of alerts updated daily, and we can use those as a feed for new targets, new and interesting targets. Again, the web link is at the bottom of that, and I would encourage you to have a look at these projects and feedback to me what you think of them. As a result of the work on Gaia, and there are other examples of this, not as many as we would hope, obviously, but there are certainly examples of where we've worked with students and teachers and been able to include them on legitimate peer-reviewed papers. So that's a really nice sort of additional string to our bow in that respect. Here are some web links, some screenshots of the different parts of the Gaia alerts, including the gaia.ac.uk website, where you can find out, and your students and teachers can find out anything they want to know about the Gaia mission. Like I say, this is all done through the National Schools Observatory in Liverpool. They are the hosts of this, using a combination of NSO and Faulkes Telescope data. The NSO provides access, and there's links at the bottom there on how to register if you're interested in the project in terms of the work I've been doing, or more broadly. I'd really encourage you to do that. And also, it's sort of a hot off the press, we are now working within an Erasmus Plus program called Last Skill, working with our colleagues in Greece, in Portugal, and in Austria, and we will be creating new resources. So the remit for our next 2 years on this project is to look at digital tools, online learning, and how to access and explore data archives and big data. So that feeds in a sense to this kind of IBSE type approach of, that there is loads of data out there, but providing the resources and the framework to allow students to actually make a meaningful attempt at doing that. Just to finish off, there are lessons learned, and hopefully this is the sort of the message that I want to sort of finish off and impart to people who are listening. We want our students to do these projects because they are a very nice way of getting an insight into the scientific process. So planning how to collect data, collecting the data, analyzing it, and reporting it back. That's the scientific process, but we're doing that within a framework in that sense. Because of the way the projects are structured, we think that they are collaborative. We can give many students lots of individual data sets. They can then work together on a common goal, which is, again, a very nice part of what science is all about. It allows them to look at maths in context, things such as periodicity, trend lines, logarithms, and error bars. And it gives them this idea of independent research and not always working towards the one single answer. And what we hope as well is that it will encourage the students to design their own little spin-off projects, make their suggestions for how these projects can work more favorably. Problems and hurdles. There are always problems and hurdles with these types of things. The clusters project, for example, is 40 web pages. That's a lot of material, but we try to find the balance between giving them all the information they need and not giving them too much information. Hopefully we're getting that just about right. We're aware that there's an installation of software issue. There are different platforms such as Linux, such as Mac, such as Windows, lots of operating systems. Some schools have firewalls. So we look at software that is easily installed, that is a free download. And in the case of GS9, of course, it's browser-based. So we're sort of beating that problem away at least. Students are not always working towards this the answer is 12 type answer. So again, there's a little bit of a conversion factor and an adjustment to be made by the students and teachers in that respect. And while we provide sample data sets, we're also aware that when students actually start to collect their own data, it comes with all the things that real data comes with, such as noise and such as variable image quality and so on. So we're aware of those kinds of things, and also the timescales. Sometimes for the work that the students have done, where they've contributed to a paper, it can be 2 years from the time the data are collected until the paper is published. So there's a timescale issue there in some respects as well, in terms of that feedback and that sort of ownership of data. That's it. I thank you very much for listening. Like I say, please have a look at the resources on the web links that I've provided, and there's some final web links and contact details for me there. Thanks for your time.